The searchlights cut through the November darkness, illuminating something extraordinary. November 19th, 1939, Hankel's test facility in Rostock, Germany. The prototype emerged into the glare, sleek, massive, built on promise. This was the machine that would answer America's flying fortress. This was Germany's answer to everything the Allies could throw at them. The engineers had given it 4 engines, coupling them in pairs to match what the Americans had achieved with the B-17. On paper, the numbers sang. 3,400 miles of range, 16,500 pounds of bombs, speed that would leave anything the Allies possessed looking ancient. Reich Minister Goering called it perfection on wings. But inside those streamlined nacelles, the reality told a different story entirely. 2 DB601 engines, 12 cylinders each, had been crammed into a space that was never meant to hold them. Daimler-Benz engineering at its most powerful and most reckless. Each engine pushed 1,200 horsepower. The designers had forced them to share a single cramped compartment built for half that power. Oil lines twisted over and under each other. Exhaust manifolds ran dangerously close to fuel injectors. Coolant ducts bent at angles that seemed to violate the laws of physics itself. Everything was compressed, everything was compromised, everything was pushed to its absolute limit. Major Horst von Riesen, a decorated test pilot, studied the blueprints with the careful eye of a man who had flown too many damaged aircraft to be impressed by promises. His finger traced the oil return lines. He measured the clearances between components that shouldn't be anywhere near each other. He calculated what the heat would do in climb, in cruise, in dive. Then he wrote his report. The words were sparse and clinical. The language of a professional who understood his warning would likely be ignored. The cooling margins were insufficient. The coupled engine configuration created unacceptable fire risk. The aircraft would burn. 12 minutes into its first flight, when oil temperatures spiked to 135 degrees Celsius, the pilot aborted. By May 1940, 5 prototypes had experienced fires. By 1943, 60 crew members were dead. Most never saw combat. Germany had attempted to copy American long-range bomber design, but one command from Hitler had transformed an engineering challenge into something far more sinister, a death trap that would burn far more reliably than it would ever fight. August 25, 1940 changed everything. The RAF sent bombers toward Berlin itself. Hitler was away, attending a Wagner opera at the Bayreuth Festival, insulated from reality in the company of German cultural heritage. The bombs fell on the residential districts of Kreuzberg and Wedding. The damage was minimal. 11 people dead. Scattered fires that firefighters extinguished by morning. From a military standpoint, the raid was almost meaningless. From a psychological standpoint, it was devastating. Hitler returned to the Reich Chancellery at dawn, his face white with fury. He demanded answers. He summoned Hermann Göring and required an explanation for how British bombers had penetrated German airspace and struck the capital of the Third Reich. Göring stood before him in his ornate white uniform from the previous night's reception, and he had nothing. The Luftwaffe had been designed for a war of speed and maneuver, devastating over Poland and France. But it had been built for short distances. The Junkers Ju-88 medium bomber, the backbone of German air power, carried 4,400 pounds of bombs and covered 200 miles before returning. Perfect for supporting tanks crossing Europe, useless for striking back at enemies far away. The Heinkel He-111, Germany's other workhorse, had nearly identical limitations. Maximum range of 1,300 miles under perfect conditions, and even then only with reduced bomb loads and prayers for favorable winds. Across the Atlantic, the Boeing B-17 Flying Fortress was already rolling off production lines. 2,000 miles of range, 4,000 pounds of bombs. Cruising altitude 25,000 feet high enough to slip past most interceptors. Service ceiling 35,000 feet. The United States Army Air Corps had ordered hundreds before America had even entered the war. Hitler knew the numbers. He had read the intelligence reports, and he knew Germany possessed nothing capable of matching it. The problem had been recognized years before, but the urgency had shifted. In 1938, the Reich Air Ministry had issued specifications for a long-range heavy bomber. The requirements were unambiguous: range beyond 3,000 miles, bomb load of at least 12,000 pounds, speed competitive with enemy fighters, altitude sufficient to evade ground fire. Heinkel Flugzeugwerke responded with ambition. The AHE-177 Griffin, conceived by brothers Siegfried and Walter Günther, the twin geniuses who had revolutionized German aviation with the streamlined HE-70 Racer in 1932. The Günthers approached this machine as an engineering puzzle with brutal constraints. Germany's industry produced inline engines, not the massive radial engines that powered American bombers. The Wright Cyclones that drove the B-17 through the sky possessed agricultural simplicity. Daimler-Benz and Junkers engines were powerful but liquid-cooled, demanding complex plumbing and precision manufacturing. 4 separate engines meant 4 cooling systems, massive drag, structural complications. The Günthers proposed something different. Couple the engines in pairs, 2 DB601 engines mounted in line within each nacelle, geared to turn a single propeller. 2 nacelles instead of 4. Less drag, higher speed. On paper, the solution was elegant. 3,400 miles of range, 16,500 pounds of bombs. Cruise speed of 340 miles per hour. The numbers surpassed the B-17 in every category. The first prototype rolled out in November 1939, 1 month after Germany invaded Poland. Photographs revealed a graceful, purposeful machine, long wings, glazed nose, twin tail, engines encased in streamlined nacelles that suggested pure speed. Test pilots circled it with professional appreciation. Even sitting still, it looked fast. Ernst Heinkel himself attended the rollout, proud of what his engineers had built. He believed the Griffin would restore Germany's technological prestige. Then Adolf Hitler reviewed the specifications during a strategic planning conference in November 1940. Hitler had been fixated on dive bombing since the Stukas devastated Poland and France. Those screaming Ju-87s plunging from the sky, striking terror into ground troops, destroying tanks and bridges with mechanical precision. Every bomber, in Hitler's view, should be capable of dive bombing. It meant accuracy. It meant psychological impact. It embodied the aggressive spirit of blitzkrieg. He interrupted the briefing. Can it dive bomb? The answer was no. The HE-177 weighed 66,000 pounds. Dive bombing would subject the airframe to 5 or 6 times normal gravity during pullout. Those forces would snap the wings off a heavy bomber unless massively reinforced. The structural modifications alone would add 3 tons of weight, destroying the fuel capacity and range that made the design worth building. Heinkel attempted careful explanation, using technical language designed not to directly contradict the Führer. Hitler cut him off with 4 words that echoed through the room. If it cannot dive bomb, it is useless, non-negotiable. The meeting concluded. The requirement was added to the specification. The Günther brothers returned to their drafting tables to solve an impossible problem. Switching to 4 separate engines would mean redesigning everything from scratch. New wings, new structure, new framework, setting the program back years. So they optimized what existed. The DB601 engines were upgraded to DB606 coupled units. 2 12-cylinder engines permanently joined, sharing a common gearbox, generating 2,400 horsepower per nacelle. Enormous power, enormous heat. The cooling system, now required to handle 2 engines instead of 1, was packed into a space that allowed no room for proper airflow or drainage. Oil lines crossed each other. Exhaust manifolds ran inches from fuel injectors. Coolant pipes bent at sharp angles to fit around structural members. Every compromise became a failure point waiting to happen. Major von Riesen, pulled from operational squadrons to test the modified prototype, traced the blueprints with growing concern. He followed the oil return lines, noting how gravity couldn't drain them properly when the engines tilted during climbs and dives. He measured the clearances between hot exhaust components and flammable fluids. He calculated heat dissipation rates against available cooling surface area. Then he wrote his report in clinical language. Oil temperature margins are insufficient for sustained high-power operation. The coupled engine configuration creates unacceptable fire risk. Recommend 4 separate engines. He paused and added one more sentence stripped of all technical hedging. This aircraft will burn. The report reached the Reich Air Ministry. The response came back within days. Continue testing. The Führer wants it to dive. Production schedules must be met. Germany needed a strategic bomber. The He-177 was the only option beyond the drawing board. So the engineers kept building, the test pilots kept flying, the fires kept starting. To understand why the He-177 kept catching fire, you had to understand what happens when you force two 1,200 horsepower engines into a space designed for one. A normal aircraft engine, like the Wright Cyclone powering the B-17, sat alone with air flowing freely across every surface. The cowling directed cooling air across cylinder heads. Oil drained downward through gravity-fed lines into a sump below the engine. Coolant circulated through wide, gently curved ducts with room for expansion and contraction. Any small leak was annoying, not catastrophic. Mechanics could reach every component for service. The DB606 violated every principle of thermal management. 2 DB601 engines, 12-cylinder inverted V, liquid-cooled, were mounted in line, one behind the other. Their crankshafts connected through a combining gearbox, driving a single propeller shaft. Each engine generated 1,200 horsepower at maximum continuous power. Together, 2,400 horsepower poured into a nacelle barely larger than what the B-17 used for its single 950 horsepower Wright Cyclone. Imagine 2 high-performance car engines bolted together nose to tail, sealed inside your kitchen oven, running full throttle for 6 hours straight. That was the thermal environment inside a He-177 nacelle during cruise power. Normal engine oil operated safely to 115 degrees Celsius. At 120 degrees, viscosity began degrading. At 130 degrees, seals and gaskets failed. At 140 degrees, the oil itself could ignite on contact with hot metal. The DB606's oil temperature in normal flight climbed to 120 degrees Celsius within 45 minutes and stayed there, writing the edge of failure for the entire mission. During a dive bombing test, 45 degrees nose down, 2,800 RPM, airspeed building past 280 miles per hour, oil temperature spiked to 140 degrees in 90 seconds. Gaskets failed. Pressurized oil sprayed onto exhaust manifolds glowing at 650 degrees Celsius. Ignition was not a possibility. It was certainty. The pilot swiftly cut power and wheeled back toward the runway following the emergency checklist. The temperature gauge showed improvement, but the needle still hovered in dangerous territory. He touched down smoothly, no drama, no struggle. But when the ground crew opened the engine cowling, they found something terrifying. A fuel line weeping fuel, like a wounded animal directly above the exhaust manifold. 5 more degrees of heat, maybe less, and the whole engine would have become an inferno thousands of feet in the air. The engineering team shrugged it off as a routine problem. They rerouted the fuel lines, made adjustments to the design, and signed off on the next test flight. May 1940 brought test number 7. This one wouldn't end with paperwork and clipboards. At 8,000 feet above the Baltic, the Wright engine suddenly erupted in flames. Not just heat, not overheating concerns, real fire, yellow and violent, flickering through gaps in the engine cowling, black smoke tearing back into the slipstream like a wound bleeding smoke. The pilot hit the ignition switch, shut down that burning engine, and triggered the fire suppression system all in seconds. Then he pushed the nose down into a diving turn, trying to force air through the engine compartment fast enough to blow the flames out. The fire suppression system sat there on the ground during testing. A pressurized carbon dioxide bottle connected to pipes that flooded the engine. It worked perfectly every single time in the hangar. Perfect. But at 200 miles per hour, with the remaining engines roaring at 1,200 horsepower, wind screaming past the fuselage, that system did absolutely nothing. The fire kept spreading, growing angrier. Mater and his flight engineer made the decision fast. They jumped at 4,000 feet. The aircraft, it plunged into a forest south of Rostock and exploded on impact with the ground. Somehow, both men survived, bruised, shaken, but alive. The accident investigators picked through the wreckage. They found fuel contamination mixed with oil residue clogging the starboard engine. Obvious problem, they concluded. Standard developmental loss, they declared. Push forward with improved fire suppression and keep testing. By March 1941, 5 He-177 prototypes had burned. 2 went down completely, total loss. 3 limped back to airfields trailing smoke and flame, engines so damaged they needed months of repair work. The test pilots started talking about it differently now. Darkly, grimly. They called it the Luftwaffe's cigarette lighter. That name spread through the testing community like a curse, and everyone knew it was accurate. Ernst Heinkel watched his company's reputation ignite, along with the aircraft. He couldn't sit still anymore. In March 1941, he submitted 40 pages of technical analysis to the Air Ministry. The words were careful, diplomatic, but the message cut straight to the bone. The coupled engine design was fundamentally flawed for what the military wanted this aircraft to do. He proposed starting over. 4 separate engines instead of 2 mated pairs. Junkers Jumo 211s or BMW 801s, proven designs with solid service records, each one mounted independently with its own cooling system and maintenance access. The airframe would need reinforcement for the extra weight and drag, and they'd have to abandon the dive bombing requirement entirely. But the result would be an aircraft that could actually fly strategic bombing missions without cremating its crew in the process. The response came back within 2 weeks. It wasn't a technical response. It was political. The Führer had declared dive bombing capability non-negotiable. The coupled engine design was essential for meeting weight requirements while maintaining range. 4 separate engines meant complete redesign, pushing the program back at least 2 years. Germany needed a strategic bomber now, not in 1943. Fix the cooling, improve the fire suppression, redesign the oil return system. But don't question the basic design. The order had come down from the very top. Siegfried and Günther, the twin engineers famous for solving impossible aeronautical puzzles, suddenly found themselves trapped in a political impossibility. They understood the bitter truth. You couldn't fix the cooling system, not really, because the problem wasn't engineering failure. It was physics. You cannot cool 2 massive engines squeezed into a space designed for one without adding coolers, ducts, and radiator surface area. All that extra equipment meant more weight, more drag, and every bit of it ate into the performance advantages the paired engines were supposed to deliver. Every solution created 2 new problems. Larger oil coolers meant thicker plumbing, heavier installations, more complexity, more places for failure. Better fire suppression meant heavier bottles and more pressure lines. Improved seals lasted a bit longer, but still failed eventually under temperatures no rubber or metal seal was designed to withstand. The engineers did what engineers under authoritarian pressure always do. They optimized the impossible. They enlarged the oil coolers. They upgraded to dual-bottle fire suppression. They replaced magnesium panels with steel to contain flames longer. They rerouted fuel and oil lines through the coolest sections they could find. They added exhaust shrouds to shield anything flammable. Each modification made the He-177 burn slightly less often. Never safe, never truly safe, but slightly less catastrophic. And each one added weight that chipped away at range and bomb capacity, eroding the entire reason for building this coupled engine monstrosity in the first place. By late 1942, the A5 variant weighed 4,000 pounds more than the original prototype, carried 2,000 pounds less fuel, and still caught fire with mechanical regularity that made every flight a gamble with thermodynamics. 3 years of engineering, 3 years of testing, 3 years of crashes, and they'd only proven what one test pilot had written in a single sentence back in 1939. This aircraft will burn. The system simply refused to believe him until the body count made disbelief impossible. The test pilots stopped making jokes about the fires around the time the death toll passed 20. The dark humor that had helped them cope with flying a machine everyone knew was dangerous simply evaporated. Something harder and quieter took its place. They still climbed into the He-177 because those were their orders. The Luftwaffe didn't accept refusals from decorated combat veterans, period. But their post-flight reports grew increasingly blunt, stripped of any diplomatic cushioning that might soften what they were describing. These were men who'd flown combat over Poland, France, and Britain. They knew risk. They knew what acceptable looked like. The He-177 wasn't acceptable risk. It was bureaucratic murder happening in slow motion. Captain Werner Baumbach filed his report after his first He-177 flight in June 1942. Baumbach wasn't a test pilot. He was an operational bomber commander, holder of the Knight's Cross, credited with sinking over 200,000 tons of Allied shipping flying Do-88s over the Atlantic. The Air Ministry pulled him from combat specifically because his credibility couldn't be dismissed. If Baumbach said the aircraft was unsafe, people would listen. His report read like an autopsy of a living patient. Takeoff normal, climb to 10,000 feet. Oil temperature, port engine, 125 degrees Celsius. Starboard 122. Both in the yellow warning zone. Leveled off at cruise power, temperatures dropped to 118. Attempted 30-degree dive per Air Ministry requirements. At 280 miles per hour, the airframe shuddered. Oil temperature spiked to 138 degrees Celsius. Smoke visible from the port nacelle. Aborted the dive at 7,000 feet. Emergency landing executed without incident. Post-flight inspection found cracked oil return line and fuel residue on the exhaust shroud. His recommendation was unambiguous. Do not clear this aircraft for operational service under any circumstances. The Air Ministry's response arrived within days. Continue testing. That phrase, always that phrase, like a bureaucratic chant repeated until it lost connection with the reality it was supposed to govern. Continue testing meant keep flying an aircraft that had already killed 18 test pilots and flight engineers in fatal crashes. 28 emergency landings due to in-flight fires. 60 dead aircrew, all before a single combat mission. In the same period, 1940 through 1942, the B-17 had flown over 5,000 combat sorties across the Pacific and European theaters. The comparison wasn't lost on anyone strapping into the He-177 each morning, wondering if today would be the day the oil temperature spiked past 140, and the engine compartment became a crematorium at altitude. The redesigns kept appearing, each one announced as the solution that would finally make the He-177 safe. The DB606 coupled engine became the DB610. Power output climbing from 2,400 horsepower per nacelle to 2,950. More power meant faster speeds, better climb, improved performance across the board. It also meant more heat concentrated in the same inadequate space. Oil temperatures rising faster, fires burning hotter when they ignited. The A1 variant gave way to the A3 with supposedly improved fire suppression. Steel panels replaced magnesium, redundant extinguisher bottles, better seals around fuel and oil connections. The fires still happened. The A3 became the A5 with redesigned engine mounts and upgraded cooling systems. The fires continued. Each variant addressed specific problems from previous crashes while ignoring the fundamental flaw. You cannot make a safe bomber by bolting two engines together in a space too small to cool them properly. January 1943 brought the He-177A5 into full production. Factories in Rostock, Oranienburg, and Vienna began turning out aircraft at 30 per month. Impressive by German manufacturing standards, laughable compared to American production lines stamping out B-17s at over 300 per month. But for the Luftwaffe bomber crews who'd been promised a strategic bomber for 3 years, 30 per month felt like salvation arriving at last. Operational units began receiving He-177s in September 1943. Kampfgeschwader 40 and Kampfgeschwader 100 elite bomber wings stationed in France took delivery of enough aircraft to equip 2 full squadrons. Aircrew gathered for conversion training practically vibrating with anticipation. Finally, a bomber with the range to hit targets hundreds of miles beyond reach. Finally, an aircraft that could strike Soviet industrial centers far behind the front lines. Finally, something that could carry the war to the enemy's strategic heartland, the way B-17s were systematically destroying German cities. The first operational loss came October 23, 1943, before the He-177 even flew its first combat mission. An aircraft from KG-40 was conducting a simple training flight, navigation practice, no bomb load, an experienced crew. On takeoff from Bordeaux-Merignac airfield, the port engine caught fire at just 400 feet altitude. The pilot, Oberleutnant Franz Stiegler, had no altitude to work with and no chance of reaching the emergency landing field. He brought the aircraft down in a controlled crash into a maintenance hangar at the runway's edge. All 5 crew members died on impact. The fire that followed spread into the hangar, igniting fuel stores and killing 6 ground personnel who couldn't escape. 11 men dead, 0 enemy involvement. The He-107 had scored its first operational victory against itself. The crews stopped being excited. Training continued because orders were orders, but the atmosphere transformed from anticipation to dread. Pilots swapped stories about emergency procedures, debated whether to attempt forced landings if fire started or bail out immediately. They developed superstitions. Certain aircraft had engines that ran cool. Those ones were flown whenever possible. Others had earned reputations as fire traps and were avoided. Maintenance personnel started refusing to fuel specific aircraft after dark, claiming they could smell fuel vapors that meant leaking lines. None of it was official policy. None of it was acknowledged, but all of it was real. Training and operations planning continued. Losses continued accumulating. By December 1943, the He-177 had been operational for 3 months. Production had delivered 415 aircraft. The B-17, in the same time frame, had reached 6,981 total aircraft produced. But the numbers that counted were operational ones. The B-17's combat loss rate over Europe stood at 4.2%. High, brutal, but sustainable when factories were manufacturing 300 replacements monthly. The He-177's loss rate was 40% total, and most weren't from enemy action. They were takeoff fires, climb fires, altitude fires, landing fires, aircraft burning on the ground, aircraft burning in flight, aircraft killing their crews without ever seeing an enemy fighter. In December 1943, Kampfgeschwader 40 submitted a formal request to return their He-177s and receive Do-88s instead. Denied. Kampfgeschwader 100 submitted the same request in January 1944. Also denied. Crews began requesting transfers to any other unit. Some got approval quietly, without explanation. The Luftwaffe was hemorrhaging experienced bomber crews not to Allied fighters, but to an aircraft built by their own side. The H-177 was supposed to be Germany's answer to the Flying Fortress. Instead, it was becoming a liability, consuming resources, killing experienced men, accomplishing nothing the Do-88 couldn't accomplish more safely for half the cost and half the complexity. By spring 1944, Germany was losing on every front that mattered. Allied bombers struck German cities daily in systematic destruction the Luftwaffe couldn't stop. The Red Army advanced westward through Ukraine and Belarus, crushing German divisions starved of air support. Invasion of France was coming. Intelligence painted a clear picture. Massive Allied buildup in southern England, thousands of landing craft, millions of tons of supplies staged and waiting. Germany needed its strategic bomber more than ever. The He-107 was supposed to be that weapon. Instead, it could barely stay airborne long enough to matter. The aircraft reached its moment of greatest shame precisely when it might have finally justified its existence. From winter 1942 into 1943, the German Sixth Army found itself surrounded at Stalingrad. 300,000 men trapped in a frozen city, severed from any supply lines, slowly perishing from hunger and the brutal cold that consumed everything. Survival demanded 800 tons of supplies arriving every single day. Hermann Göring, desperate to restore the Luftwaffe's credibility after its humiliating failure to prevent Allied bombers from devastating German cities, gazed at this crisis as an opportunity. He stood before Hitler and made a promise. The airlift could work. His bombers could do it. The He-177, with its cavernous bomb bay repurposed for cargo, could theoretically transport 4 tons per flight. The mathematics looked encouraging on a map. 50 sorties daily would mean 200 tons delivered, still nowhere near the 800 needed, but enough to sustain operations while a rescue force fought its way through. Goering issued orders. 12 He-177s were committed, another 6 diverted from other duties to transport work. These aircraft would depart from airfields scattered across Ukraine, flying deep into Soviet territory toward Potomnik Airfield, nestled inside the Stalingrad pocket itself. They would carry ammunition, precious medical supplies, and whatever food could be stuffed into their converted cargo holds. It was transport work, nothing exotic. No combat flying, no dive-bombing runs, just straight movement of supplies under conditions that slower, more obsolete Ju-52 cargo planes were managing regularly despite their age and fragility. If the He-177 could not accomplish this, it could accomplish nothing. 3 aircraft erupted in flames before ever reaching the city. 2 turned back as their engines faltered and quit, their crews deciding suicide was not preferable to continuing onward. 1 more crashed deep in Soviet-held territory after its crew parachuted to safety. 2 additional machines abandoned their runs when mechanical gremlins made pushing forward feel like accepting certain death. 4 He-177s actually deposited their cargo at Potomnik, 18 tons total, enough to feed 300,000 starving men for roughly 4 hours. 3 machines crash-landed in Soviet territory on their return journey when exhausted engines simply surrendered. The Stalingrad airlift became the moment when the He-177 might have proven worth as a transport aircraft, if nothing else. Instead, it delivered a 75% loss rate and negligible impact on whether the trapped army survived. The 6th Army surrendered that February. The He-177's reputation perished alongside them. Ernst Heinkel observed his life's work becoming a synonym for catastrophic failure. He composed a secret memorandum addressed to Albert Speer in April 1944. Speer had risen to Minister of Armaments in 1942, holding authority over German war production. Tasked with eliminating programs that devoured resources while delivering nothing of value, Heinkel's message was not technical analysis. It was confession and despair. The coupled engine layout was never something I designed. It was forced upon us by that dive-bombing requirement imposed in November 1940. I warned then, in 1940, that cooling 2 engines within a single nacelle violated every aerodynamic principle and created unacceptable fire risk. Every modification since those early years has been mere cosmetics. Improved fire suppression, better seals, upgraded cooling systems, but the core flaw cannot be addressed without abandoning the coupled design entirely, switching instead to 4 independent engines. That would demand beginning completely anew. A full redesign consuming 3 years at minimum. We have now wasted 415 aircraft, 150 million Reichsmarks, and 60 lives pursuing a machine that will never function reliably. I formally petition for the program's termination and redirect of all production resources toward proven designs. Speer replied with exactly 2 sentences. Production will continue until operational requirements are satisfied or superior options emerge. Concentrate your efforts on improving reliability metrics. This was not technical judgment. This was political calculation. Cancelling the He-177 meant acknowledging the entire program rested on a fundamental mistake from its conception, that Hitler's dive-bombing order had doomed it before the first prototype ever left the ground, that the Reich Air Ministry had burned 4 years, denying what every engineer recognized. No one inside the German High Command possessed the courage for such honesty in 1944, as the war visibly collapsed around them. Scapegoats mattered more than truth. The He-177 received one final opportunity to demonstrate its value in July 1944 following the Normandy invasion. KG-100, the Luftwaffe's premier bomber squadron, operated He-177s from Bordeaux in southwestern France. Their assignment was stark and strategic. Attack the Allied supply vessels moving through the English Channel, severing the logistical artery sustaining the entire invasion. This was precisely the mission the He-177 had supposedly been engineered for. long-distance strikes against high-value targets, leveraging superior speed and bomb load to penetrate enemy defenses. If the Grief could achieve anything, somewhere, anywhere, this was it. 12 A-177s climbed away from Bordeaux on the evening of July 14, 1944. Each carried 2,000 pounds of ordnance and sufficient fuel for the 6-hour round journey to the Channel and back. One aircraft became engulfed in flame within 20 minutes of leaving the runway. The crew parachuted across occupied French territory. The bomber plummeted into a vineyard, exploded on impact, and killed 2 French civilians toiling in those fields below. 3 additional 177s abandoned their runs as engine temperatures climbed into the danger zone, troubling vibrations developing throughout their airframes, smoke pouring from the nacelles. They retreated before entering contested airspace. 8 bombers reached the English Channel. Stretched across the water lay dozens of supply ships moving eastward toward the Normandy beaches, protected by destroyer escorts and fighter patrols overhead. The HE-177s descended to 15,000 feet and released their ordnance. Few bombs struck their targets. Most splashed harmlessly into the water. 2 vessels reported minor damage sustained. No sinkings achieved. Spitfires descended upon the bomber formation, shooting down 2 He-177s before the survivors scattered and raced for home, engines screaming. One additional Grief touched down at Bordeaux with collapsed landing gear, its structure buckling under the impact. Inspection afterward revealed stress fractures spreading through the mounting points, likely consequences of all those reinforcements added for dive bombing, modifications never adequately tested. From the 12 that departed, 5 returned intact. 2 fell to enemy fighters. 4 were lost to mechanical failure or uncontrolled fire. 1 was destroyed during landing. 0 strategic benefit resulted for the Allies' operational situation. The KG-100 commander filed a mission report recommending immediate removal of the He-177 from all operational duties. His recommendation was acknowledged and disregarded. By August 1944, with American forces streaming across France and Soviet armies pressing toward East Prussia, Albert Speer finally authorized cessation of He-177 production. Manufacturing would pivot toward fighter interceptors instead. Germany required fighters capable of defending against Allied bombing campaigns, not strategic bombers that ignited before reaching their targets. Nobody stated this truth officially in any document. Everyone involved understood it perfectly. The He-177 had failed so comprehensively that manufacturing additional examples proved worse than possessing no strategic bomber whatsoever. A total of 1,169 aircraft left factories. Approximately 1,060 operational missions were flown. 40% of all machines built were lost, the vast majority to mechanical catastrophe rather than enemy weapons. The B-17 presented an entirely different accounting. 12,731 were manufactured. 291,588 combat sorties were completed. 4,735 were lost from all causes: fighters, flak, mechanical failures, weather, landing accidents. Each B-17 that survived combat averaged 61 missions before retirement or destruction. Some surpassed 100 missions. The Memphis Belle became famous for reaching 25, not because that number was extraordinary, but because it achieved this milestone early enough to transform into a propaganda symbol. Dozens of flying fortresses eventually exceeded 100 missions. The name Flying Fortress reflected unglamorous dependability rather than technical wizardry. 4 independent engines meant survival redundancy. Lose a single engine and the bomber continued flying. Lose 2 and it limped homeward. Maintenance demanded only basic skills and fundamental tools. Components remained standardized across production versions. Damaged B-17s received repairs. Lost B-17s were replaced by 3 more rolling off production lines. The aircraft was not revolutionary, it was adequate. Mass-produced, present in overwhelming quantity. The He-177 embodied opposite philosophy entirely. Germany pursued excellence through precision, each bomber a carefully crafted instrument, optimized for performance manufactured to tolerances requiring master labor and scarce materials. The coupled engine arrangement appeared elegant on paper, reducing aerodynamic drag and increasing velocity. Dive bombing capability satisfied doctrine inherited from early Stuka successes. Range and bomb capacity matched or exceeded Allied equivalents. But excellence divorced from reliability transformed into expensive ruination. The He-177 flew faster than a B-17 whenever its engines did not catch fire. It carried heavier payloads when its structure did not fracture. It dive-bombed effectively when G-forces did not crack its airframe. Every capability carried a dangerous condition attached. Every condition killed airmen who had faith the machine would behave as promised. Germany manufactured 1,169 Greifs. America manufactured 12,731 flying fortresses. Germany lost 40% of its strategic bombers to mechanical failure. America lost 1.6% per sortie, predominantly to enemy action. The numbers inhabited entirely separate categories of competence. The lesson was simple, brutal, and inscribed across European wreckage in scorched metal and shattered dreams. Germany attempted copying America's long-range strategic bomber but imposed a dive-bombing requirement that fractured the design before prototypes ever flew. Hitler's command in November 1940, "Make it dive," sealed the fate of 1,169 aircraft and 230 airmen condemned to death through political override. Engineers who recognized the coupled engines spelled danger wrote reports that got buried. Test pilots who logged fires and structural failures were ordered to continue despite everything. Combat crews who refused flying the He-177 faced court-martial threats. Institutional inertia propelled the program forward long after every participant recognized its doom, because admitting failure meant confessing that one man's judgment had been catastrophically wrong. And nobody in Hitler's command structure possessed the will for such honesty, while theoretical victory remained possible. A burned-out A-107 abandoned in a Berlin field. Come May 1945, its coupled engines exposed and melted into deformity, conveyed truth more eloquently than any official report. Soviet soldiers walked past without pause, just another piece of German ruin in terrain saturated with wreckage. An American technical intelligence officer stood nearby recording serial numbers and specifications for files destined for distant analysts who had never experienced combat flying. A final notation appeared at his inspection report's conclusion: He-177 Greif, ambitious conception, fatal realization, operational value, 0. Germany's effort, matching the B-17, failed, not because German engineers lacked ability, but because political demands overwrote engineering reality, until nothing remained except a bomber that ignited more reliably than it dropped ordnance. The He-107 burned from more than overheated engines. It burned from institutional friction between ambition and reality, friction that killed 230 men who never possessed opportunity to fight genuine enemies, only the aircraft their orders demanded they trust.